The last time we got together, we were working on looking at a trig function and figuring out what its graph would look like. Today we're going to go in the opposite direction and look at the graph and determine what the function is. And again, this is later. We'll get to that eventually. Determining an equation from the graph of a sinusoid. This comes right from your notebook. Suppose you were looking at this graph. Could you figure out what its equation was? The questions you need to ask yourself. Is it a sine or a cosine? Well, that means we already have recognized that it's a sinusoid. If it's a sinusoid, we can either call it sine or cosine. What is the difference between them? It's only a phase shift. Where is the curve's axis? So here we're talking about the central axis. If the peak is at 5 and the valley is at -1, the central axis is going to be midway between them, right? So if we go down 1, 2, 3, and we go up 1, 2, 3, we find that the central axis is right here. Now what does this tell us? This is going to tell us how much this graph has been translated up or down. So the curve's axis, what is the sinusoid's amplitude? An amplitude, we know, is the measure from that central axis. Good idea to have already figured out where that is. What's that distance? In this case, we can see that it's 1, 2, 3. So in this case, it's 3. The curve's axis was at y equals 2. We still haven't talked about whether it's sine or cosine. We'll get to that. And what is its period? Well, we know the period by looking at what point does a sinusoid begin to repeat itself. So we can look at the 5 critical points: the beginning, the midpoint, the end, the valley, and the peak. For sinusoid, that will do it. So what is the period for this one? We can see that it's 180 degrees, which is a frequency of 2, isn't it? We are cycling twice in 360. Decide whether it's sine or cosine. If it starts at a high or low point, call it cosine. If it starts near its axis, call it sine. So in this case, we'll call this a sine curve. Decide if the curve is reflected. It's reflected if A is negative. Well, if this were reflected, instead of going up here, it would be going down. So we can tell that A is going to be positive. We draw the axis of the curve exactly midway. That's going to be our D. We find the height of the curve above the axis right here. That's our A. Find the period by inspection. Since the period is 360 degrees divided by the frequency, we can always figure this by saying B is 360 divided by whatever the period was, which in this case was 360 divided by 180, which was the 2 that we already talked about. Is there a phase shift? If the curve is shifted right, in other words, if it's midpoint, its axis, that starting point of the curve, were over here a ways, then we'd say C was positive. If, on the other hand, it was back this way, we'd say it's negative. Knowing which sinusoid function and the values of D, vertical translation, A, amplitude, B, frequency, and C, phase shift, you can write the equation. So what would the equation of this one be? This would be y. We've already said it's going to be sine, right? So let's put that in. And we do have a vertical translation of 3. So we're going to have a positive 3. We are not reflected, so this is going to be, oh, wait a second. I don't think I left myself quite enough room. Let me just give myself a little more room. 3, because I do need to think about amplitude, don't I? My amplitude is 3, and it's normal. It's not reflected, so it's going to be a positive 3. So plus 3. My frequency, I've already determined, is 2. There is no phase shift. If there were, I'd be writing x minus whatever that phase shift was. In this case, no phase shift, so it's a little simpler. I'll go ahead and erase the 2, I guess, since I already erased part of it. So we just put the frequency is 2x. So we now can look at a graph and determine an equation. For each of the graphs below, find an equation that generates it, and then verify using the calculator. Good idea. You remember what happened to me? Gee, wasn't it just the last session that if I hadn't verified, I wouldn't have caught my error? So pretty important to verify. For each of the graphs below, find the equation that generates it. So what do you think here? Should we use sine or cosine? It's starting high rather than at the midpoint. So probably we want to be thinking cosine. And where's the central axis? We're moving between a positive 1 and a negative 3. If I move up 2, I get to negative 1. If I move down 2, I get to negative 1. So this is the central axis for this curve. So let me see, the central axis represents my D, doesn't it? So it was shifted down 1. Whoops, down 1. Ordinarily, my parent graph would have been right here. This one was shifted down 1. What else are we thinking about? Oh, amplitude. The amplitude is the distance from the central axis to the peak. So my amplitude is, that's right, 2. Is this normal or reflected? Well, this is normal. It's starting high and going low. So when I write my equation, it's going to be positive. What else do I have to figure out? Oh, frequency. What's the frequency here? Well, the period I'm seeing is 360 degrees. So there's no change in frequency. It's 1 cycle per 360 degrees. Good. So my B is equal to 1. And what about a phase shift? Is this shifted either right or left? No, it's a 0. So I've got y equals negative 1 plus 2 cosine x. Oh, that's kind of messy. I got lazy. I should have just written the whole thing out fresh. Sorry. It's negative 1 plus 2 cosine x. Let's try it on our calculator to make sure we've got it right. Now remember, we do have to check mode. For me, every time it comes up radian. For you, it's going to come up with whatever you last used. What else do I have to do? My window. So I'm going to set my window at 0 to 360. Okay, 0, 360. With an X scale of, what are we showing here? From, it's showing 30 degrees. We use that. An X min of -3. Whoops, that doesn't look good. 30. An X min of -3. An X max of 1. X scale of 0.5. Okay. Now we'll go to y equals, and we'll put in -1 plus 2 cosine x, and we'll graph it. Yes! Does that look right? Oh, the only thing that's, one thing I want to check on the window. What did I do on the window? Oh, my y scale. Yeah, it does look a little strange, doesn't it? I meant to have an X max of 1 and a y scale of 0.5. You probably noticed it, and I didn't. Okay, now we'll graph. And now we see the right number of tick marks there. So that's evidence that I do have the right formula. I was able to reproduce the graph. Let's do a couple more. We've got plenty of time here today. Now, of course, you can be doing these on your own. You don't have to be doing them along with me. Okay, this one is starting pretty much at its midpoint, so I'd say this one we probably want to use sine. Say y equals, and it looks like its high point is 3 and its low point is -3, so I don't have any vertical translation, right? My d is equal to 0. My amplitude looks like that's A. Whoops. Looks like that's 3. And it's not reflected, right? It's normal, so it's going to be a +3. So I've got 3. And my period, I'm having a little bit of a hard time reading this thing, but it looks like it starts at, what do you think that is, 30 degrees? I do, 30 degrees. Oh, come on. Every time I try to do a degree sign, it wants to recognize some fancy letter. And over here, it looks like it's going to 390, wouldn't you say? Because each one of these tick marks is 30. So it's going from 30 to 390. Well, that's 360. So my period is just what you'd expect in the parent. My frequency is 1. I'm getting 1 cycle in 360 degrees. What about my phase shift? I do have a phase shift, don't I? It's going this way. It's going this way 30 degrees. So my phase shift is 30 degrees. So what is my equation going to look like? Y equals 3 sine, and then we're going to have parentheses here, x Remember, it's minus whatever your phase shift is. So for a positive phase shift, minus 30. Let's pull up that calculator and make sure I haven't made some silly error. I'm very good at the silly errors. Okay, do I want to change my window? You know, I do. I do want to change my window. I'm going to start at 30, and I'm going to say my max is 390. I'm still going to have X scale of 30, and I'm going to be a minimum of -3 and a maximum of 3. A Y scale of, this time we will go with 1. Okay, so I've changed my window. My Y is going to equal, let me clear this out, 3 sine, I'm going to say X minus my positive phase shift, and now we'll graph it. It looks beautiful! Yes! Alright, so we did that one well. You want to keep going with me, or you want to do these on your own? I'm going to keep going, and you can just do it on your own. Just turn down the volume and do it on your own, but I'm having so much fun. It's true, I actually like these. Well, in case you heard a little rumbling there, you know what a teacher does in the summertime? She prepares her lessons for the following year. What you're hearing is an August thunder shower outside my windows. Okay, here I'm looking for where the center is. My valley is at 1, my peak is at 3, so my central angle appears to be right there. So I've got a shift of 2, don't I? It's gone up from 0, well, here's 0, 1, 2. My amplitude looks like that is 1. And what do you notice here? It's not rising to start, it's falling. So actually I'm going to have a negative on my equation. This is going to be reflected. What is the period that I'm looking at here? It's going to take a minute to figure that out. Well, I guess this is 0, 30. If each of these tick marks are 30, then here we're at 120, aren't we? So I've gotten a full cycle in 120 degrees. So I probably need to do a little calculation here. That means that I've got a frequency which is greater than 1. I've got 360 divided by 120. That's the period that I found in my equation. 360 is the parent. So I've got a B of 3. That's my frequency. And do I have a phase shift? I don't. There's no phase shift here. So my equation. Oh, I didn't even talk about whether it's a sine or a cosine. I'd say because we're starting pretty much in the middle here, that we're going to use sines. We're going to say y equals our vertical shift of a positive 2 minus, because we're reflected, 1 times sine, and it's a frequency of 3. Alright, so let's pull over our calculator and check for some foolish error. Believe me, it's easy to do. We're going to start off with adjusting our window. This time we're going to start our minimum at 0. Our maximum is going to be at 120. Our scale is going to stay 30. Our y min will do just like we've got here. It'll be 0. And max will be 3. And the scale, we'll put it at 0.5. I try to match it to the graph that you're looking at. Now we're going to do y equals, let's clear this out, 2 minus sine 3x. I always hold my breath when I do this. Hey, that looks great. Nothing to worry about. Let's try this one. By the way, these are all sinusoids. Where's the tangent? You know, maybe I better watch my time and go forward. We'll let these be ones that you do in class. Because I want to talk about tangent. Oh, and I also better talk about the reciprocal partners of sine and cosine. We know that they are cosecant and secant. Get rid of this. Get rid of this. So symbolically, when we talk about cosecant, it looks just like this. The domain, every place that sine was 0, cosecant is going to have an asymptote. Range, all numbers except those between the peaks and the valleys. So what am I talking about here? We're not going to see anything where sine would have been. The same thing is true here. We're not going to see anything where cosine would have been. All right. So all numbers except between the peaks and the valleys. All numbers except between the peaks and the valleys. So these are very similar to one another. Just like sine and cosine, the only difference between them is a phase shift. What do you notice here? Here's your asymptote at 0 degrees. Here's your asymptote at pi over 2. So you got a phase shift of 90 degrees. The tangent function, I've been waiting to work more with this one. We've done a little work with it. We know from SOHCAHTOA, our very first exposure to trig, that tangent is opposite over adjacent. We're more sophisticated now. We say our opposite is y, our adjacent is x, it's y over x. It's nice. We never, with tangent, we never have to worry about the hypotenuse. Cotangent, well, there's not much different here, is there? This is the reciprocal partner of tangent, and it's simply x over y. What's going to be different is where you get your asymptotes, right? The other difference will be when you go to graph this one, it will start high and end low. Let's go back here. With tangent, you start low and end high between the asymptotes. Okay, let's just look at this. I'm going to reveal these little t-charts. Tangent, the domain everywhere except the asymptotes, and that's because we can't let the denominator go to 0. So every place that, go back here, every place that x is 0, where does x equal 0? Right here at 90, and then at 270, and so forth. Every place that x would equal 0, we have an asymptote. Becomes undefined. And in the case of cotangent, oops, don't go back that far, every place that y is equal to 0, you're going to have an asymptote. And that happens at 0 degrees, it happens at 180, and so forth and so on. So here we are at 0, we have our asymptote. At pi, or 180, we have another one. So domain not at the asymptotes. Please notice, with both tangent and cotangent, there is no restriction at all on the range, because you're either going from negative infinity to positive infinity, or, in the case of cotangent, coming from positive infinity and going to negative infinity. Represent a trig function in 3 ways. Let's go back a moment. There are 3 ways used here. Symbolically, really what we're talking about is right here. There's the symbolic. We've got, the domain and range, that's interesting, but that's not part of the symbolic representation. For a numerical, it's this whole table. And if you take it through one cycle, if you're doing a numerical representation, that's good enough. Particularly when it's done in conjunction with a graph. And of course, with a graph, you want to show all your asymptotes in whatever window you have chosen. Make sure your window, if you want to show the periodicity of, oh, I actually said it, of a function, you want to make sure you show at least 2 cycles. Okay, 2 cycles would be enough. You don't have to do as many as I did. Although there is, at least for me, a tendency to go from negative 360 to positive 360 and see what I get in that window. Okay. Develop a table of values for cotangent. Now I'm going to leave this for you to complete in class. Okay, that's going to be what you do in class. See you there.